Hey guys, this is the video explaining why we're going to do lab 2 and a couple things you need to know before coming into the lab. The main thing for this lab is learning how to use the equipment and less of learning the physics principles behind it. We do this because labs 3 through 9 are very equipment heavy, and if you don't know how to use the equipment, you're not going to do well, no matter how well you know your physics. So we want to introduce all the equipment early on so you can get familiar with the equipment, and then later on when the physics gets harder, you can spend more of your time thinking about the physics rather than the equipment because you got used to the equipment early on. In the rest of the video, I'm going to show how to measure the resistance of a resistor, the voltage across a resistor in a circuit, and the current through a resistor in a circuit. These are all things that will be very important to know during the lab. Now we will learn how to measure the resistance of resistors using a multimeter. So here I have 3 resistors, our multimeter. First, we begin by plugging a banana wire with an alligator clip into the COM port, then another banana wire with an alligator clip into the input port. Then, since the units of resistance is ohms, we will turn the knob of the multimeter to the ohms symbol. Now, all we have to do is attach the one alligator clip to one end of the resistor and the other alligator clip to the other end of the resistor, and there we have our resistance. To measure the resistance of another resistor, we simply remove that one and attach the alligator clips to another resistor. And one more resistor. And we are done. That is how you measure the resistance of resistors using a multimeter. Now I'll cover how to measure the voltage across a resistor in a circuit. So here we have a resistor on a breadboard, and here we have the power supply attached to the resistor. Now to measure the voltage across this resistor, we're going to turn our multimeter knob to volts. We'll then attach the multimeter probes, one to COM, one to input. We'll attach the alligator clips to either side of the resistor. Here we read that there's 10 volts across the resistor. What this means is that the input port is 10 volts higher than the COM port. Since these wires are equipotential surfaces, that means this side of the resistor is 10 volts higher than this side of the resistor. What happens if I switch the two wires? Let's see. The two wires are now switched, and we now read negative 10 volts. What this means is that the COM is now 10 volts higher than the input, which is the same result we got before. This side of the resistor is 10 volts higher than the other side of the resistor. That is how you measure voltage across a resistor. Now we will learn how to measure current using a multimeter. Current is the most difficult aspect of a circuit to measure. First, we must calculate the theoretical current. If the theoretical current is less than 500 milliamps, we will use the input jack. If the theoretical current is more than 500 milliamps, we will use the A jack. For this circuit, the theoretical current is 5 milliamps, which is less than 500 milliamps. So we'll use the input jack. Then we will turn our multimeter to milliamps, since that is the unit of our theoretical current. If you want to measure DC current, you can stay there. If you want to measure AC current, you hit select and it'll switch to AC. If you hit select again, it'll switch back to DC. For now, we will be doing DC current. To measure the current in a circuit, we must break the circuit and use the multimeter as the connection. Here, I will break the circuit. the circuit is now no longer connected. The battery goes to the resistor, which ends there. We need to connect the resistor back to the negative port of the battery. We will use the multimeter to build that bridge. We will connect the positive alligator clip of the multimeter to that end of the resistor, and the negative port of the battery into the multimeter. We now have 5.06 milliamps running through this circuit. Notice that the circuit is not the same as it originally was. This multimeter used to not be in the circuit. Now it is a part of the circuit. The multimeter also measures the direction of current. If we were to switch the COM and the input, then our current now measures as negative. A positive current means that the current is flowing from the input to the COM. A negative current means that the current is flowing from the COM to the input. The multimeter is simply placed into the circuit at the point where we would like to measure the current. Then we restore our circuit back to its original form. That is how you measure the current in a circuit. There's two things I couldn't show from that above view because the quality was too low. The first thing is that when you're measuring the resistance of a resistor, the multimeter displays the units right there. So here we have 357 ohms, I think, if I'm reading that backwards correctly. If I were to use a different resistor, then you can see the change in units. So here, this resistor has units of kilo ohms. You see that little K right there? It'll be easier to see when you're in the lab, but just remember to pay attention to your units according to the resistor. So this one is actually 1.995 kilo ohms, okay, which is 2,000 ohms ish. The other one was 330 ohms, not kilo ohms, so pay attention to that unit. The other thing was, if you forget how to decide which jack to use, the input or the A, when you're measuring current, you can look at this fuse here. So here it says fused at 500 milliamps. That means if you run a current between the COM and the input that is larger than 500 milliamps, you will blow the fuse inside of here, and I will be very upset because it's a pain in the butt to fix that. And you will not have a multimeter for the rest of the lab, or I'll have to get you a new multimeter. So if you're measuring a current larger than 500 milliamps, use the A and the COM. And if you're measuring a current larger than 10 amps, then just don't measure it because you will break the multimeter. The COM and the A can only take a maximum of 10 amps, as it says right there. That's how you know.